Okay, now we're going to look more carefully at question 2. So in this one we have a motorcyclist with a total mass of 200 kilograms travels the journey shown in this graph. This is a speed time graph. Whenever you see one of these graphs, make sure you check what it is that's plotted on the y-axis. In this case it's speed. Calculate the acceleration of the motorcyclist during section A of the graph above. Okay, so we know that A is equal to the change in speed over the change in time. In this case, the speed changed from 0 to 40, so the change in speed is 40. And the change in time was from 0 to 5 seconds, so that change took 5 seconds. So the acceleration here is 8 meters per second squared. Alright. Calculate the net force on the motorcyclist during section A of the journey. Well, we know that the force must be equal to the mass that's being accelerated times its acceleration. And we were told in the question that the mass was 200 kilograms. So that's 200 times 8. And 200 times 8 is 1,600. And force is measured in newtons. So it's 1600, and the unit is newtons. Construct a distance time graph for the motorcyclist on the graph paper on page 4. And then calculate the distance traveled during each section, A, B, C, of the speed time graph. In fact, so this top bit says construct the distance time graph. If we go through all the steps that lead up to it, then we should be able to do that with much less difficulty. So for section A, the distance covered, remember the distance covered is the area under the graph. So we've got these three areas to look at, right? So section A, the area is half base times height. So that's going to be half times 5 times 40. And for this one, for a rectangle, it's just base times height. So that's 5 times 40, because the base length here is 5 and the height is still 40. And here we have another triangle, but this time the base is 10 long. So let's go half times 10 times 40. So 40. Okay, so those three areas, the sum of those should be the total distance, and each one of those should be the distance for each bit. So let's put that in here. So for section A, the distance is half times 5 times 40, which is, well, half times 40 is 20, 20 times 5 is 100 meters. For section B, we had the rectangle, right? So that was 5 times 40, which is 200. And then for C, we had that longer triangle, which was a half times 10 times 40. Oops. Half times 10 times 40, which is 200. And so the total distance is 100 plus 200 plus 200, which is 500 meters. We should really have units on all of these. Okay. So those are the distances. So let's copy those into this table. So for the here we're going to have 100. That was 200, and that was 200. And for the distance time graph, we're going to want to plot the total distance covered. So for this one, it was 100. Then 100 plus 200 is 300. 300 plus another 200 is 500. Okay. So now we want to plot this on the graph. Okay. So we noted that the first section, the speed time graph, was increasing. So this is distance now. And that's measured in meters. And so we will go, the time is 5, 10, 15, and 20. And then vertically, the total distance we want to have covered is 500. And so how many squares we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if we go up in hundreds, if we divide that by 5, we're going to get here 400, 300, 200, 100, and our graph should always start at 0. Okay, so now for the first 5 seconds, we know that the motorcyclist got to 100 meters, and we know that the motorcyclist was accelerating during that time. Okay. Oops. And for the second 5 seconds, we know that he traveled a further 200 meters, so that's up to there. And then for the next 10 seconds, we know that he traveled while decelerating all the way to there. Okay, so this distance here, he was traveling at a constant speed, so we can draw a straight line between those two. For the first 5 seconds, the motorcyclist was accelerating, so that should be a curve upwards like that. And for the last 10 seconds, the motorcyclist was decelerating, so that should be a curve that flattens out like that, because the gradient is how fast the motorcycle is going. Okay, put in that here, seconds. So that's the key to this graph, is recognizing that there was an acceleration here, and then we have constant speed here. That didn't really work, but okay, and then we have decelerating here. And you need to remember what acceleration and deceleration looks like on a distance time graph. Okay, then it says, using the information above, calculate the average speed of the journey. Okay, so V average is always equal to D total over T total. And D total here was 500. And the total time that's passed was 20 seconds. So 500 over 20 is 25 meters per second. Okay, so that's question 2. We'll have a look at question 3 in a separate video.